except really understanding those trig values. All right, so the unit circle, we got a little taste of it yesterday, but here's the big unit circle. A unit circle is special because it has a radius of 1 unit. Okay, so if it's the unit circle, everything is 1 away. So you want to really look and see if it says the word unit circle in the question. That means you automatically know the radius. The circle is centered at the origin. For some generic point, x, y, in the first quadrant, the length of x and y become the legs of a right triangle. Whose hypotenuse has a length of 1 because it's a radius. All right, the equation of the unit circle. So let's think about the equation of a circle. What makes this a circle? It has to have how many squared terms? 2. So the circle is x squared plus y squared equals the radius squared. And if it's a unit circle, it has a radius of 1. So 1 squared is 1. Okay, so here's what we're going to do. It says we have some point P. So let's put some point P on the circle. Okay, now trig is all done on what shape? A triangle. This is all about a triangle. So you're going to start at the origin, just like we've done a million times the past 2 weeks here. You're going to go over, and we're going to go up, and you're going to create a right triangle. That is one of those bow tie pictures. Okay, if I went over, what do we typically call that distance? It is positive, but what variable might we use? X. And if we went up, we might use the variable y. Now, because they're telling us this is a unit circle, what does that tell me the length of the radius here is? 1. Okay, so go with me on this. So we're going to call this point P. All right, so let's put theta in our angle. Let's find the sine of theta. All right, so based off our picture, the sine of theta in words is who over who. What 2 words am I always saying? O over h. So my O is y and my h is 1. So I get y over 1, which is really just y. Let's do cosine theta. Cosine theta in words is who? Adjacent over hypotenuse. So in this case, it's going to be x over 1, which is really just x. So you've just discovered what every point in trig is called. In our math world, we usually call the point x comma y, correct? But in trig, x is equivalent to cosine, and y is equivalent to sine. So in trig, we're going to call every point cosine theta, sine theta. Nope, every point on this unit circle is cosine theta, sine theta. Now the signs will change, Dree, whether they're positive or negative. So if you're stuck on this, instead of drawing this out every time and you're thinking cosine and sine, just think alphabetical order. X comes before y, C comes before x. It's cosine first, sine second. Okay, so Dree says, well, how about another quadrant? Is this the same every place? I don't know. Let's put a point here. Okay. Let's draw our triangle. So we're going to go out to the left. And we're going to go up, and we're going to make that right triangle, centered at the origin. Now think about this. If you went to the left, what would you call this distance now? Negative x. And I went up, what would I call that distance? Positive y. So I like to think this point is negative x comma y, but in the trig world, we're going to call it negative who? Negative cosine, comma, positive sine. Okay, do we understand why it's negative? We went negative, and then we went positive. Now, let me give you another reason that you should understand it's negative. If I call this all students tip cows, who's the only term that should be positive? Sine, and cosine should be negative, right? Based off just the positive trig quadrant, sine should be positive. and cosine should be negative. Do you think this is going to work in every quadrant? Sure. What if I put the point down here? They're both going to be negative. Let's draw a triangle. I'm going to go out this way and down. This is why we draw the picture every time so you can see the signs. This distance is going to be negative x. This distance is going to be negative y. Therefore, I'm going to get, what would my point be called? You got it. Negative cosine, negative sine. All right, let's do this for fun. Let's throw an angle in there. Let's say we had, let's say they told us this is angle 315. And the question is, what are the coordinates of this point? I want to know what the exact coordinates are of that point on the unit circle. Okay? This is very simple. It's all based off what we've been doing for days now. We're going to draw our triangle in to get to this point. So we're going to go over some, and we're going to go down. We've got our right triangle, but we need this reference angle. How am I going to get this angle if I know this is 315? 360 minus 315. If it ends in a 5, I better know it's what number? 45. Anything that ends with a 5 is a 45. It's either a 30, 60, or 45. Okay, so now look how simple this is. What do I know about this x distance? Positive, and the y distance? Negative. All right, so now we're not going to write it with theta. We're going to write it with our angle, 45. We're going to say this is the positive cosine of 45, comma, negative sine of 45. Now you know this coordinate because you know these answers. So you should know this. What is the cosine of 45? Root 2 over 2, comma, negative, what's the sine of 45? Root 2 over 2. And that is the coordinates of that point. That's what you're going to be asked to find most of the time, are the coordinates of that point. Okay. Let me come back to this picture, and I'm just going to throw an angle at us. When if I said this was, make a little arc here. When if we call that angle 240? 240. So now in my triangle, what's my reference angle? 60. It's either a 30, 60, or 45. How do I know it's 60 and not 30? 240 minus 180. It's to the x-axis. That's all we did. We said reference angles are to the x-axis. This is a 60 degree. So this is really negative cosine of 60, sine of 60. And again, are those numbers you're supposed to know? All right, so what are the coordinates here? What's the negative cosine of 60? What's cosine of 60? 1/2, comma. The sine of 60 is root 3 over 2. Okay, so it's always somebody you know. That's why you had to memorize that table. It's always going to be a multiple of 30, 60, or 45. All right, in our last example here, we're going to redraw this triangle for yourself in the first. We'll put our point P here. We're going to drop our triangle down. Sometimes they'll ask you to identify the line segments which make up the trig values. So let's think about what we already have discovered so far. The x distance is considered which trig distance? This is the cosine line, yes. The y distance is considered the what distance? Sine. Okay, they are inside the unit circle. Cosine is x, sine is y. Now think about your geometry days. What did the word tangent mean? That's exactly it. The line touched the outside of the circle once. So it's none of these lines because these are inside, correct? So I have to draw a tangent line. It's literally going to come out and just touch the circle once. And it is outside of the circle. Draw that and label it the tangent line. A tangent line touches the circle, outside of it once. That was a great explanation, Dree. How about a secant line? That was another word you used in geometry. Not only does it touch, but it goes through the circle. So if I extend this right here, this is my secant line. It goes through that circle and touches it. It can actually come out the other end here. Touches it twice. Okay, so your tangent and secant are outside. Tangent touches it once. Secant's going to go through. Cosine and sine are sitting inside, your x and your y. All right, so keeping that in mind, look at this diagram and label these 4 line segments. Okay, like from where to where is sine, cosine, tangent, and secant. Again, from your geometry days, a line segment is made up of 2 letters. Pick 2 letters that make up the line, from where to where. Right, so this is the angle. This is the reference angle, which is fine. You can put the theta in the triangle to help you discover anything. All right, so I'm hoping this is pretty straightforward. Sine and cosine are inside the circle. Tangent and secant are outside the circle. Okay, who is my x distance? The x value, right? X is my cosine. So I'm going to highlight this. I go over here and up here to get to the point on the circle. So my x distance, or cosine, is my OS or SO. Just put a line over it for a line segment. My y distance to get to that point is my sine. So that's my SQ or QS. Okay. My tangent touches the circle outside of it once. What 2 letters make that line? PR, good. And my secant goes through the circle, so that's going to be P to O works. And obviously you can extend that line to go through if you're thinking that. Okay. All right, we're going to introduce one more. I want you to make one more circle at the bottom here, one more unit circle. So put your axes. Okay. One more time, what does unit mean? How far away? 1. We have to understand unit means 1. When they tell us it's a unit circle, it means it's 1 away. So now you actually know 4 more values here. If this is the origin and this is the unit circle, what are the coordinates of this point? Which one is it? Is it 0, 1 or 1, 0? 1, 0. I went over 1 and up 0. What are the coordinates of this point? Coordinates. 0, 1. I went over 0, up 1. What are the coordinates of this point? Negative 1, 0. And the coordinates of this point? 0, negative 1. Okay. Now you know 4 more values. This is equivalent to how many degrees? 0 and 360. This is equivalent to 90, 180, 270, and back to 360. So we can add all of these to our table of values that you have to know. If I asked you what the sine of 0 is, you should be able to go to 0, say the coordinates are 1, 0. Which of these represent sine, the x or the y? The y. So the sine of 0 is 0. When if I said the cosine of 90, cosine of 90, go to 90 degrees. You know the coordinates. You can close your eyes and think of them. That's 0, 1. Who's the cosine, the x or the y? X. So the cosine of 90 is 0. When if I said the sine of 180, sine of 180, you're picturing the coordinates. Who am I looking for? The y, which is going to be 0. Okay, you know these four coordinates. Everybody should know those. There's nothing new there. And you're saying the x value or the y value. So now, not only do you know 30, 60, 45, you should know 0, 90, 180, 270, and 360. And those are always 0, 1, or -1. Okay? We'll keep playing with them. All right, here's what you're going to have to do. Number 1, determine the ordered pair that lies on the unit circle. I want you to highlight the word ordered pair. Okay, you are looking for a point. You should be able to tell me the exact point on the unit circle. Okay, so when I see 30, every point is x comma y, but in trig it's called cosine theta, sine theta. Okay, that's what we've just spent the first 15 minutes talking about, cosine theta, sine theta. So if I see 30 degrees, this is really the cosine of 30, comma, the sine of 30. Are they both positive? Where does 30 fall? Quadrant 1, where all are positive. So I'm going to put that in parentheses, and then I'm going to go get its point. What is the cosine of 30? 3/2, comma, the sine of 30, 1/2. Okay, you've got to know the trig values. I told you they don't go away ever for this whole unit. All right, 150. So I'm going to make a quick axis. Where is 150? Quadrant 2. Okay, who owns that quadrant? Sine. So I need the cosine of somebody and the sine of somebody. 150. Now 150 is not a number I know. Is it a 30, 60, or 45? How far from the x-axis is it? 30. So is cosine going to be positive or negative? Negative cosine of 30. Positive sine of 30. So this is going to be negative root 3/2, comma, 1/2. Do we see how it's somebody from our table of values? It's always a 30, 60, or 45 until I get to the next one, 90. All right. I want you to picture 90. Tell me the coordinates at 90. 0, 1. So that's it. 0, 1. Easy peasy. 90, 180, 270, 360. You know those coordinates. All right, 300. Figure out what quadrant you're in. I heard a 4. Okay, what's my reference angle? 60, good. 60 away from the x-axis. Who's positive, who's negative here? All students tip cows. So cosine is positive and sine is negative. So I'm writing positive cosine 60, negative sine of 60. So my coordinate should be 1/2, comma, negative root 3/2. Think you got it? It's always a 30, 60, or 45. You've got to be really careful whether you're positive or negative. Now, just again, common sense. If I said 300, wouldn't you go a positive x and a negative y? So this should be positive and this should be negative. Just use common sense. All right, now we're going to go backwards. Point P is negative 1/2, negative root 3/2. Figure out the angle. All right, so let's make a little sketch here. If you went negative 1/2, negative root 3/2, plot where you would end up. Negative 1/2, negative root 3/2. What quadrant should you be quickly sitting in? 3 is perfect. You went negative, negative. Everyone agrees with that? Okay, I need to figure out this reference angle. So it's either a 30, 60, or 45. This number here represents which value? Okay, so the cosine is negative 1/2, and the sine is negative root 3/2. What one number gets us both those answers? 60. The cosine of 60 is 1/2, and the sine of 60 is root 3/2. So my reference angle is 60. Now, can 60 be the answer in the third quadrant? No, it's got to be 180 plus 60. 180 plus 60, my angle is 240. Make sure you pick an angle in that quadrant. It's just a quick way to say the measure of the angle. I'm going to skip 3 for a second, come down to number 4. Find all the values that satisfy the equation cosine theta equals 0. Okay, now, is 0 in our table of values? No, 0 is a point on the unit circle. Is cosine x or is cosine y? X. So I want you to picture your unit circle. You can help yourself and draw it. You basically want to know when the x value is 0. Which of these points have an x value of 0? 90 and 270, right? If you wrote the coordinates here, this is the coordinate 0, 1, and this is the coordinate 0, negative 1. So my answers are 90 and 270. Correct, because you could keep wrapping around the circle an infinite amount of times, yes. So it's just saying, tell me the ones just from here to here. All right, go ahead and try 5. Figure out what quadrant you're in. Figure out what your reference angle is based off that point. And then what your big angle is. Okay, picture's worth 1,000 words. Plot a quick point. What quadrant are we in? Everyone agree too? I want negative, positive. So my answer has to fall between what two numbers? 90 and 180. So if this is multiple choice, I'm going to cross anybody off that's not between 90 and 180. Does that make sense? Okay, now you should know the exact value because it's root 2 over 2, root 2 over 2. When is cosine equal to root 2 over 2 and at the same time sine equal to root 2 over 2? Answers, okay, now 45 isn't the answer, so don't fall for that because that doesn't fall between those two. But that tells me I'm 45 away. So how am I going to get my angle? You got it, because I have to be between those two, 180 minus 45. And again, if it's a 45, it ends in a 5. This would be a 135. 135. All right, try the next one. The point 0, 1 falls on the unit circle. What is the angle? Figure out where 0, 1 falls. 0, 1. Where do you plot the point 0, 1? 90 degrees. Easy enough. So anytime it's a 0, 1, or negative 1, it's just one of those 4 points. Just plot it. Everything else is coming from the table. All right, flip to page 316. Okay. Without looking at any previous stuff, I just want you to fill in what you can in the first quadrant. Give me the degrees in the first quadrant. Let's just focus on quadrant 1. Give me the degrees. Yep, just label, start here, and just label all those degrees from here to here. Because if you got that, you can get any quadrant. We start at 0, what's this one? 30, 45, 60, and up to 90. Easy enough? Okay, every point xy is called who? Cos theta, sine theta. Every point is cos theta, sine theta. So now we're going to go get all these coordinates. Easy, easy, easy. Let's start with 0. If this is the unit circle, what is this coordinate here? 1, 0. I went over 1, up 0. Okay, so now all I'm saying to myself is I want cosine, sine. What's the cosine of 30? Perfect. Sine of 30. 1/2. That's it. That's the coordinate. Easy. Now go to 45. What's the cosine of 45? Sine of 45. Done. Easy. Go to 60. What's its cosine? 1/2. And then the sine of 60? Okay. How simple is that? You already know all of this. All right, now let's put our radians on. 0 is obviously 0 radians. 90 we said was how many radians? Pi over 2, because 180 is pi, right? We said that's pi over 2. We cut it in half. Okay, how about 30? Pi over 6. We're just saying, we're comparing it to 180. How many 3's into 18, or 30 into 18? Pi over 6. How about pi over 4? Oh, shucks, I just told you the answer. How about pi over 4? 4 45's in a 180. And how many 60's in a 180? Pi over 3. Okay. Now, once you have this quadrant, they're all multiples of each other. This quadrant dictates the entire thing. I'm going to put one last point up here. What are the coordinates at 90? 0, 1. Okay. Here's the magic. You're just going to take this and reflect it over here. Okay, so let's reflect this over. If this is 30 away, that means this is 30 away. What's our degree? 150. That's a 180 minus 30. Okay, now the coordinates are the exact same because it's still 30 away. The only thing that's going to change is whether it's positive or negative. If I went this way, what do you know about the x value? So it's negative root 3 over 2. And then I went up, so that's going to stay a positive 1/2. Okay. Now let's get our radians here. How many 30s are in 150? 3 into 15 is 5, so that makes 5 of these. So 5 pi over 6. It's going to stay pi over 6. You just say you have 5 of them. All right, let's do the 45. This is 45 away, so this is 45 away. What does that make that angle? 135. Remember, it's got to be between 90 and 180. 135. How many 45s are in 135? So that's 3 of these. So that's 3 pi over 4. And now we need the point. What do we know about the x value? Negative, and it's still the exact same as it is here. Negative root 2 over 2, positive root 2 over 2. All right, this guy's 60 away, which means this guy's 60 away. What does that make that angle? 120. Does that make sense? Okay. It's a pi over 3, so I'm just saying how many 60s are in 120. So that's 2 pi over 3. It's going to stay the same. Okay, so this point is still the same. It's just the x value is negative. And then we can get this main guy. We said this is 180. It's equivalent to pi, because we multiply by 180 over pi, or pi over 180. And its coordinate is negative 1, 0. All right, try the next quadrant. It's the same distance away. The same distance away is going to have all the same features. The only thing that's changing is whether it's positive or negative. I just want to stress, all these 30s away are going to be the exact same coordinates, just their positives and negatives are changing. So if this is 30 away, that means this is 30 away. What does that make this? 210. And then I say how many 30s are in 210? 7, and that's a pi over 6. So it's just 7 pi over 6. Coordinates are the same, except what do I know about both of them here? If I went over and down, they're both what? Negative. So negative root 3 over 2, negative 1/2. Does that make sense? It's the same exact thing. Okay, while I have this highlighted, I'm going to do this one as well. This is also 30 away. What does that make this angle degree? 330. How many 30s are in 330, or 3 into 33? So that's 11 pi over 6. They're all pi over 6s, all those 30s. Coordinate-wise, the x value is positive, but the y value is negative. So root 3 over 2, negative 1/2. But you get, once you have the first quadrant, you really have all of them. Okay, I'm going to do let's try to find a different color here. I'll use red here. I'll do the 45. So everybody on the 45 line should be the exact same. So if I'm 45 away, I have to be between 180 and 270. What does that make this angle? 225. Okay. How many 45s are in 225? 5. Perfect. That's 5 pi over 4. And if I went left and down, both of my values should be negative. Negative root 2 over 2, negative root 2 over 2. I'm going to get this 45 this way, since they're all the same. If I go 45 from here, now I get that 315. They all end in a 5. This is 1, 2, 3, 4, 5, 6, 7 pi over 4. Okay. Coordinates are going to be the same, except the x value is positive and the y value is negative. So the y value is negative. Okay. Last one, we'll hit the 60s. Okay. So if I'm 60 above 180, that's going to put me at 240. How many 60s are in 240, or 6 into 24? 4 pi over 3. Coordinates stay the same, except the x is negative and the y is negative. So negative 1/2, negative root 3 over 2. Okay. Same on this tail. I'm 60 away, so this is 360 minus 60 is 300. 60 goes into 35 times, so that's 5 pi over 3. Coordinates are the same, except I'm a positive x and a negative y. Okay. And then lastly, I think I just got this 270 here. Its coordinates are 0 and negative 1. I went over 0, down 1. And I might just be missing my radian. 270 is made up of how many 90s? So that's 3 pi over 2. And then I go to my 360, which is my 2 pi. And that's really it. Once you know this quadrant, which you should by now, it's very, very straightforward because it's just a reflection into every single one. Just really got to watch those positives and negatives. Let's flip this paper over real quick. Let's do a question or two in each section. All right, just to make sure we're on the same page. Let's talk this out. A unit circle, a unit corresponds to a length of 1. Good. The equation for the unit circle is x squared plus y squared. 2 squareds make it a circle, and if it's a unit circle, it's equal to 1. It is centered at the origin and has a radius length of 1. Can we get this in our head yet? Unit means 1. Every point xy on the unit circle is going to be represented by who first? Cosine theta, comma, sine theta. We didn't talk about this one yet. Don't worry about 4 yet. All right. Draw a rotation for each angle and then determine the ordered pair. Highlight that ordered pair. They want the point. We need the point on the unit circle. All right, so we can draw out a 330. What quadrant is 330 in? 4. All right, so I'm going here. What is our, so 330 is not a number I know, but I need its reference angle. What is its reference angle? 30. 360 to 330 is 30. And I'm going to write let's talk about who's positive, who's negative. What do I know about the x value? So positive cosine of 30 and then negative sine of 30. And then I just need my answers. The cosine of 30 is 3/2 and then comma negative 1/2. Okay. You should common sense be able to narrow some choices out by just being what's positive and negative. If you wanted to get to this quadrant, you would have to go a positive and then a negative. Just narrow some choices out. All right, let's try 8. 2 pi over 3. Is it easier for you in degrees? Let's just convert it to degrees. Take 2 pi over 3 and convert it to degrees for yourself. What could you multiply by? What's that? You got it. Or you could just do it. Which would be nice. What do we get for this? 120. All right, so what quadrant are we in? 2. What do I know about my x and my y there? Okay, so I need a negative cosine of something and a positive sine of something. What is my something? What is my magic degree? 60, because I'm going to the x-axis. So my coordinate should be negative 1/2, comma, √3/2. Okay. All right, let's jump to 12, just so we're all on the same page. Now we want the angle. All right, so let's figure out where we are. Where is negative √2/2, negative √2/2? Everyone good with quadrant 3? Negative, negative? So tell me what your answer has to fall between. Between 180 and 270. Make sure you pick an answer between 180 and 270. What is the reference angle? 45. Okay, so you went to this point here, and your reference angle is 45. What are you going to do to get that angle? I need a number in this quadrant with a reference angle of 45. Who minus who? 180 minus 45. That's what we did for reference angles.
Is that supposed to be in quadrant 3?
It should totally be in quadrant 3. Just seeing if you're paying attention, Sarah.
How do you get the 45?
Where did 45 come from? Because it's √2/2. This is the cosine and this is the sine. That's a good question. Are we on the same page with that? This is cosine and this is sine, and the angle that makes that happen is 45. So I actually want to be between 180 and 270. So what does that get me? What am I doing with those numbers now? Adding. 180 plus 45 should get me 225. Okay. And then I think the rest is everything we've done here. So your homework is this page. You are going to rip this out and turn this in. Make sure your name is at the top so we don't have any names that aren't turned in. Put your name at the top right now. See if you can get another one under your belt. It's all about that reference angle.